So the problem that we are trying to solve with this project is a human needs to be present to analyze the football game to manually tell when a penalty kick is happening. Our goal for this project was to create a system that could extract the moment that a penalty kick happens in a video of a whole match or a small buffer of frames. One of the main issues that we had to tackle in this project was the lack of tooling for our proposed solution and labeled data for this exact problem publicly available. While researching the problem, we noticed that the penalty kick can easily be characterized by looking at the motion of the kicker relative to the ball. Taking note of this, we decided to base our system around analyzing the motion of the kicker during the run-up stage of the penalty. During this stage, we were also unable to find labeled dataset that works with our proposed solution to the problem, along with the fact that it is difficult to come by high-quality football videos that we could use, making an unsupervised approach infeasible. Therefore, we went with manually creating a labeling pipeline that would allow us to collect data for training the classifier. To create our training dataset, we first started off with acquiring the raw video footage supplied to us by our client for this project. We have to then slice those clips into individual frames, which are then fed into our detection pipeline, where we use YOLO v5 object detection on those frames combined with sort tracking for humans. After that, a human labeler would label the start and end frames of the event, and all the tracking data during that period of frames would get either stored locally in a JSON or stored in a PostgreSQL database. By using a hosted database, we allow for the possibility of multiple labelers working on the task concurrently. The labeled data can then be requested by the training script and used to generate a dataset, which will then be pre-processed into a usable form for the classifier. The ResNet classifier is then trained using the pre-processed dataset. The last few steps could also be done on a cloud computing platform like AWS SageMaker to speed up the process by using a fast GPU. This chart describes our video processing pipeline. First, a YOLO v5 object detector is run on the frames to detect humans, which is then followed by a sort tracker. This allows us to follow the human's movement across multiple frames. Each new frame, the array with all the tracked humans in the buffer is updated. If the buffer gets long enough, in this case 20 frames, it is then pre-processed to change from flat coordinates of humans and the ball into human acceleration relative towards the ball. This buffer is then fed into the signal classifier, which determines which event takes place. This slide shows a few examples of what a run-up signal could look like in the final normalized dataset that the classifier is trained on. As you can see in this example image, the kicker has been correctly identified, him having the words "run up" above his head, while other humans that the detector has noticed, due to their movement, have other assigned to them. We have managed to deliver to the client a Python package containing APIs for continuing development and scripts to help build the dataset and run the inference. The dataset is possible to be built either locally or using the database that has been specifically configured for storing the labeled data. Documentation that explains how to make use of each stage of labeling, training, and using the pipeline. We have cloned the repository with this project in AWS for the client. Delivered a small set of labeled data that was used for initial training of the classifier. Thank you for your attention.